Hello, this is 1.2 notes on simple random sampling. This is page 2, and we'll get to page 3 as well. Our goal for this lesson, continued from page 1, is to be able to determine best practices for using a census versus a simple random sample. In this recording, it's 2020, and we are currently in a census year. So you may be aware of the significance of taking a census in order to understand the ideas and input of an entire population. And you'll see throughout this year an increase in the efforts to make sure that each individual citizen of the United States has completed a census so that we have a great understanding of the population of the United States. This is done every 10 years. So it's a survey distributed to all. A lot of effort and time and even money goes in to doing a census of that scale. We can do a census of smaller populations, such as a classroom, we'll talk about in a minute, where there wouldn't be quite as much effort, or a census of the student population of Butler Tech, and that would be, you could even call the paperwork that you turn in at the beginning of the year, and introduce all of that information. If that data were gathered and analyzed and then re-communicated, that is a great source of information. You could consider a census of the population of Butler Tech. Now, sampling is when we take a part of the population. So we often use a sampling to make those conclusions, draw conclusions about the population, just by surveying part of the population. We do this by using random devices such as a coin toss, a table of random numbers, a random number generator, a variety of different ways to do a sampling. To best understand responses of the entire class, which would be a representative sample, that is the key to being able to draw accurate conclusions about a population based on a sample. So you'll see if we just sampled the boys in the class, that would not represent the entire class unless it was maybe at an all-boys school. We could sample only the vocalists at School of the Arts, and again, in our typical academic classes, that is not representative of the entire class. The sampling of all students simply from Fairfield High School, being a school of choice, we have 13 different school districts feeding into our one school district, and so just sampling from one high school would not represent the entire population. However, just sampling half of the student responses at random would be a representative sample, because that has the opportunity to include all of the different homeschools, all of the different arts majors, and the variety of male, female, all the genders within those responses to represent our school. So more on a representative sample. A representative sample reflects as closely as possible the relevant characteristics of the population under consideration. By using a representative sample, we eliminate unintentional selection bias. We've all heard that term, bias. We're going to unpack that throughout the course. A sampling procedure for which each possible sample of a given size is equally likely. So we have a typo there. I apologize for that. Equally likely to be the one obtained. The sample must be representative in order to use inferential statistics. We talked about that in our last lesson. Inferential statistics, to draw conclusions about the entire population. You see the word inference within that word, so Again, just drawing conclusions about the entire population. Using a sample, it is so important that that sample represents the entire population from which it was drawn. A biased sample, on the other hand, is a sample chosen to represent the population where either intentionally or unintentionally interprets a part of the population instead of the whole. So if I were trying to get new drum sets for School of the Arts, and I really wanted to have a statistic that seemed very bold and significant, maybe asking the question of how, on a scale of 1 to 10, what is your urgency to get a new set of drums for the building? I might only sample the students that are in instrumental music. In that case, I would have you would expect to see a lot of 8s, 9s, 10s, versus if I sampled all of the different departments, you might see that number a little bit lower, the average of those ratings. Methods for obtaining a simple random sample. Again, there are a variety, like we talked about up above. And simple random sample, that is a type of sampling. In our next lesson, we'll talk about several different types of sampling. Simple random sampling can generate, it is a common use to collect a representative sample. So we have random number tables. Random number tables can be used, and they are a simple process if you just pay close attention to this portion, because obtaining an SRS, simple random sample, by picking slips of paper out of a box is usually impractical, especially when the population is large. We use several practical procedures to get a simple random sample. One method is the table of random numbers. So it's a table. These numbers are just randomly generated. And you can see they're organized in columns and rows. And so in this example, you have a class of 50 students, and we're going to use the second row. It tells us where to start. And it says we're going to use, we want a sample of 3 students. Now we know the students are numbered 1 to 50. And you notice these are both 2-digit numbers. So what are the numbers of the 3 students selected? And then these would be our representative sample that we would then survey. So we start and we go in row 2, 2 digits at a time, and we will jot down the numbers that fall between this range 1 to 50. 76 is the first 2-digit number, not between 1 and 50. 34 is the next 2-digit number. It is between 1 and 50. So our first student that we would survey would be number 34. And you just keep on going. Even though there's a gap here, we just keep going. So the next number would be 86, not between 1 and 50. The next one is 91. Nope. 72, nope. 95, 93. Here we have, again, we stretch across the columns, the number 18. The next student we would survey would be number 18. 95, nope. And then we have 6. So we write that as 06 because it makes it 2-digit. It is just the 6th student in that set of students as numbered 1 to 50. So there you have the sample, those numbers associated with a student that we would survey. Now you'll see on the next page here, we have another example talking about, and these are great examples. The examples actually come directly from this book from Professor Neil Weiss called Introductory Statistics, and it's the 10th version. So he's done a lot of research, has a lot of resources referenced in the back of that textbook. You can find those in our classroom or online to provide these scenarios of real life situations. So we'll go through this one rather quickly. Same idea, another larger table of random numbers. We have a sampling student opinions example. So student questionnaires known as teacher evaluations. This is, again, a college atmosphere. This book is taken from a college course. Gained widespread use in the late 1960s and early 1970s. Generally, professors they hand out evaluation forms a week or so before the final. So that practice, however, poses several problems. So you'll see some bias here, unintentional bias. On some days, less than 60% of students registered for a class may attend. Moreover, many of those who are present complete their evaluation forms in a hurry in order to prepare for other classes. A better method, therefore, might be to select a simple random sample of students from the class and interview them individually. During one semester, Professor Hassett wanted to sample the attitudes of the students taking a college algebra at his school. He decided to interview 165 of the 728 students enrolled in the course. Using a registration list in which the 728 students were numbered 1 to 728, he obtained a simple random sample of 15 students. You see how interviewing 15 students, that would be a sampling rather than a census where we have 728 students total. So by randomly selecting 15 students, 15 numbers between 1 and 728. To do so, he used the random number table below. To select 15 random numbers between 1 and 728, first picked a random starting point. So in this scenario, we're all going to start in the same spot for the sake of consistency, but when you're generally using a random number table independently, you can select the spot where you begin. So closing your eyes, placing your finger, and then beginning with the 3 digits under the finger, we go down the table and record the numbers as we go. There are directions. We go down the table. So because we want numbers between 1 and 728 only, we disregard this number 000. And numbers between 729 and 999, right? Those are too large for the numbers that would actually be associated with student. To avoid repetition, we also eliminate duplicate numbers. So duplicate numbers, that's key, do not show up in our sample. If we have not found enough by the time we reach the bottom of the table, we move over to the next column of 3 digits, and this time we go up that column. So if we place our finger at random here in this column labeled 30 to 39, and we landed at the 3rd row here, marked 3rd row, we would take a look at this number 069. Again, we are looking for 15 total numbers. So 069 represents the 69th student. And then moving down, 988 is too large, so we would not write that down. That would not be one of our 15. And then 386 fits that criteria. 539 fits. 303, 97, 628. 458, yep. 759, that one's too high, it's close. 881, nope. 009, so the 9th student, yep. 36. 981 doesn't work. 652. 694. 24. 178. And then we would go back up the next column. So we are at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We need 2 more. So again, this is probably the most often confused pieces, is that you would go up that next column instead of coming back down. And again, we stretch across rows. So the next number is 849. Too big. 578. I just need one more. So 578 and then 404. And so this would be the list of 15 students that you could survey. And this is a common method used for simple random sampling for our purposes. And again, it's called using a random number table. And so we've seen a couple examples of how that works.